Question 12, Part C. A cup of coffee with an initial temperature of 80 degrees Celsius is placed in a room with a constant temperature of 22 degrees Celsius. The temperature, capital T degrees Celsius, of the coffee after T minutes is given by capital T equals A plus B times e to the power of negative kt, where A, B and K are positive constants. The temperature of the coffee drops to 60 degrees Celsius after 10 minutes. How long does it take for the temperature of the coffee to drop to 40 degrees Celsius? Give your answer to the nearest minute. This problem is an application of Newton's law of cooling. Now the model given is capital T equals A plus B times e to the power of negative kt. And our first step is to work out the values of A and B. Now initially, the temperature of the cup of coffee is 80 degrees Celsius. In other words, at time t equals 0, capital T is equal to A plus B times e to the power of 0, and that equals 80. Now e to the power of 0 is equal to 1. Hence, A plus B is equal to 80. Now, as time gets larger and larger, in other words, as time approaches infinity, e to the power of negative infinity approaches 0. So this term here, the B e to the power of negative kt, disappears. So capital T approaches the ambient temperature of the room, which is 22 degrees Celsius. Hence, A is equal to 22. And from this equation here, if A is equal to 22, then B equals 58. Therefore, the model is capital T is equal to 22 plus 58 times e to the power of negative kt. Now we need to apply a boundary condition to find the value of k. At time t equals 10, capital T equals 60. Hence, 22 plus 58 times e to the power of negative 10k equals 60, and we need to solve for k. So subtracting 22 from both sides of the equation and dividing by 58, we get e to the power of negative 10k is equal to 19 over 29. Now taking the natural logarithm of both sides and then dividing by negative 10, we get k is equal to ln of 19 over 29 divided by negative 10, which is equal to 0.0422856858 and so on in decimal. Now the question is asking for how long it takes for the cup of coffee to reach a temperature of 40 degrees Celsius, correct to the nearest minute. So we need to solve the equation 40 equals 22 plus 58 times e to the power of negative kt, and we're going to solve that for t, now that we have the value of k. So again, with some rearrangement of this equation, to make e to the power of negative kt the subject, we get e to the power of negative kt is equal to 9 over 29. Taking the natural logarithm of both sides, we get negative kt is equal to ln of 9 over 29. And then making t the subject, we get t is equal to ln of 9 over 29 divided by negative k. And we have the value of negative k, which we worked out here. And that equals 27.6706 and so on. Therefore, the coffee takes 28 minutes to cool to 40 degrees Celsius, correct to the nearest minute.